Hello, this is the video for mass and weight, and this is the last topic according to the new syllabus. Now, we have already learned that mass is a measure of inertia, and we know inertia is the tendency of an object to remain in the state of rest or in the state of motion. So, an object tends to remain in its original state of motion or original state of rest, and that is called inertia. So, mass is the measure of inertia. So, if the mass of an object is more, that means its inertia is more. And we have also learned that greater the mass, the greater is the inertia. Now, we can also say that mass is the amount of matter contained in an object. So if there is a definition of mass of an object, we can say that mass is the amount of matter contained in an object. Now, the mass of an object, whether it is on Earth or some other planet or even moon, the mass of an object remains same whether the object is on Earth, the moon, or in outer space. So, mass of an object is constant and it does not change according to the place. So, the mass of an object will remain same on Earth, it will remain same on moon, but the weight of an object will be different for different places. Now, we are going to study what is the weight. We know that the earth attracts every object with a certain force, and this force depends on the mass of the object and the acceleration due to gravity. Yes, the earth attracts every object with a gravitational force, and this force depends on mass of the object and the acceleration due to gravity. We all know that force is equal to m into a. The weight of an object is the force with which it is attracted towards the earth. So it's very simple. The weight of an object is the force with which it is attracted towards the earth, or the force with which the earth attracts the object. It's the same thing. The weight of an object is the force with which it is attracted towards the earth, or the earth attracts the object. The force with which the earth attracts the object. We know F is equal to m into a. That is, we can write in place of a, we will write g, because g is acceleration due to gravity. Now, the force of attraction of the earth on an object is known as weight of the object, and it is denoted by W. So, in place of F, we will write W. So, the formula for weight is W equal to m into g. Now, as the weight of an object is the force with which it is attracted towards the earth, the SI unit of weight is same as that of force. It is Newton. Now, we can say weight is a force, and it acts vertically downwards, because if we are carrying a bag with a lot of weight, and we have to place it on a plank of wood, and now if the bag is very heavy, the plank of wood would be just pressed down. That is, the weight acts downwards. Like if someone puts a heavy iron ball on our hand, we will feel the weight on our hands. So that means the weight actually acts downwards. It has both magnitude and direction. That means it has magnitude, that means it has a certain measurement, and it has particular direction. Now, We also know that value of g is constant at a given place. Therefore, at a given place, the weight of an object is directly proportional to the mass of the object, because weight of an object is m into g. Now, g is constant. So, the weight of the object will depend on mass of the object, because g is already constant. So if m is greater, the weight is greater. If m is less, weight is less, because g is already constant. So weight will be more if mass is more, weight would be less if mass is less. That means weight is proportional to mass. So weight of an object is directly proportional to the mass, that is weight proportional to mass. So because of this reason, at a given place, we can use the weight of an object as the measure of its mass. So if we want to know the weight of an object, mass of an object, we can use the weight of an object to denote the mass of an object. Suppose there is a ball and we want to know the mass of that ball. So we will denote the mass of that ball by the weight of that ball. Now this is very important, that mass of an object remains same everywhere, but the weight of the object depends on the location, because the mass of an object will remain same everywhere, on earth, on any planet or moon. The mass of an object, if it is placed on earth or if it's placed on moon, its mass will remain same, but the weight will change according to location, because on every location g will be different. So the weight depends on location because g depends on location. So on earth, the value of acceleration due to gravity g is different. On moon, the value of g, acceleration due to gravity, is different. So g depends on location. So weight will also depend on location, because if g is different on moon, then the weight of an object on moon will be different, because w is equal to m into g. So if g is different for different planets, the weight of an object on different planets will be different, because m will be same but g will be different. So the value of an object, a value of weight of an object on earth would be different, because it would be m into 9.8, but on moon, acceleration due to gravity is different. So the weight of the same object on moon would be different, because it would be m into the acceleration due to gravity on moon. So in case of weight, m will remain same but the g will different depending on different locations. So the weight will be different depending on different locations. On earth, the weight of the same object will be maybe 6 kg, but on moon the weight of that object will be 1 kg. So on earth and on other planets, the weight of the same object will be varying.